Hello everyone, my name is Ben Eady and I'm the online media manager of ModernAnalyst.com, the premier online community for business analysts. I'd like to welcome you to today's webinar titled Business Performance Improvements with Big Data. Today's featured speaker is Mark Marinelli from Lavastorm Analytics. The webinar will last approximately 60 minutes, including the Q&A session, so make sure to submit your questions in advance using the questions feature of the webinar software. I'd also like to say thank you to Lavastorm for sponsoring this event, and at this time I'll turn it over to Mark to get us started.
Hello everyone, my name is Mark Marinelli. I'm the VP of Product Management here at Lavastorm Analytics. Today's webinar is going to be a discussion of business performance improvements with big data. We're going to talk about applying analytical techniques to big data sources alongside traditional data sources and traditional analytic techniques for the purposes of improving business performance by having more visibility into issues that are occurring with the business and their correction. So we'll not only be talking in general about the topic, but also animating this with a particular use case from our company's history using our technology. The agenda for this webinar will be at first a discussion of changing BI and analytic needs, sort of the state of the market right now. Then big data and the unique opportunities and challenges that are brought into bear by it, the impact on the business analyst who's going to be using the data to perform their analysis, the Lavastorm Analytics platform, which I'll just talk a little bit about the software before we get into a demonstration of the particular use case that we've got using our software, and then we'll wrap it up and have some question and answer. So first, the BI, business intelligence and analytic needs of businesses have changed. Businesses are more and more these days competing on analytics in order to provide the best products and services for their customers, in order to bring to market their products and services more quickly, in order to better operate internally and be able to lower their costs. There's a big need for analytics. Those analytics require speed with which we can derive answers from the wealth of data that are available to us, speed with which we can derive accurate answers, so getting the right answer from the data. If you're going to make a decision based upon these results, you need to have an accurate portrayal of what's going on, and visibility across the board, visibility into the various parts of the business that may suggest new avenues of inquiry for analytics. This is really driven and sort of drives customer expectations. Our analytics are often a search to tailor the right offer for a customer or to target the right customer segment. Customers have become acclimated now to the types of specially targeted messages or products and services that these analyses produce. So there's sort of a virtuous cycle there where there's now a need for even more analytics to satisfy those customer expectations. All of this really leads to more complexity. It's not just that you need more data to get these analytical answers that drive your business, but you need more people involved. There's more decision makers, more people who interact with analyses, and there's always change. That is a truism in all businesses, that things will always change. The conditions of the business, the conditions of the market, they're all going to change. Examples of this complexity are fractured supply chains or fractured value chains, where you've got a whole bunch of different steps in a sequence of bringing a product or service to market, and each one of those steps has we had an error there. Each one of those steps has various systems that are producing various data, and you need to make sure that along that process, the correct outcomes are realized. And there's a lot of area in a fractured value chain between the creation of an order for a service, let's say, to the fulfillment of that order, to the billing the customer for that order, and measuring their customer satisfaction, there's a lot of room there for error, and thus a lot of room for improvement. So the good news is that using big data, using large amounts of data and performing complex analytics thereupon can improve your operations and really transform the way that you conduct business. Quoting here a McKinsey study that was published in the Harvard Business Review, customers using big data and analytics have productivity rates and profitability 5 to 6% higher than those of their peers. So that's really a tangible, measurable differentiator. Should talk about big data for a minute, and that when we'll talk a bit more about specifically unstructured data sources. But big data really that feeds into this is a combination. There's a lot of definitions out there, but the common definition is a large volume of data from a large variety of sources, which are both created at high velocity, things like transactions, and need to be analyzed with high velocity. Big data presents opportunities to discover hidden insights in business. And Lavastorm examples here, we've got customers who are, because of their ability to analyze large volume and variety of data in near real time, they can perform fraud detection, very granular fraud detection in their telecommunications networks to find out hidden, very purposefully hidden among all of that data where the malefactors are and to shut them down. They can bring in one case, we've got 60 different data sources that are all integrated to perform this sort of real-time fraud detection. The other thing that it can do, that's sort of forensic in solving a problem where the customer or some other entity is taking advantage of the business. But just steady operating business can transform and automate some of the processes that they've already got. For example, if you're doing pay by the drink billing, you need to analyze an awful lot of data in large volume and perform analyses to make sure that you're setting those price points for those services at a point where customers will tolerate them, and that you're performing the billing correctly. If they're doing pay by the drink, they're definitely going to keep an eye on how much they're consuming. And bringing in new data sources. Traditionally, you may be looking at only the delivery of a service as measured in the billing, but if you bring in new data sources like pulling data directly out of the network that is servicing a particular service, that provides a much richer data set and allows you to really automate the process from end to end. And then enriching information for better decisions. And that's really bringing in a much more varied set of parts of the problem to have a more holistic answer. For example, from one of our customer interactions, we had data from a customer service survey engine where they're measuring how the customers are recording their happiness or dissatisfaction with their service, tying that back to the orders that they placed, the installation activity that set them up with the service, and complaints from other sources, say from a website. Pulling that all together, you can have a much more informed view of what's really going on. If a customer is stating that in their survey that they've got problem X, and we look at the order and installation and find that absolutely we messed up the order and gave them the wrong installation, that's very different from someone who may have misunderstood the terms of their order and they're upset not from really our problem on delivery, but from better communication, something we can fix with better communication to the customer. So great, we can bring in a bunch of data sources and have more informed decisions, have a much more granular visibility into what's going on within our business and how it impacts our customers. That has traditionally been in the purview of BI solutions or analytic solutions where we've got all the data. We've got all of the data stored because they're our data in relational databases and mainly structured data sitting in data warehouses. But you really need to look beyond those silos because outside there are a variety of sources that will not be under your control that have important contributions to the data set that you're going to make decisions upon. In the base case, it could just be bringing in more of your own silos, unifying silos within your business. But more and more, you're going to see that some of your operational support systems, like, for instance, Salesforce.com, are their enterprise data, but they're not inside your warehouse, and they never will be. They're up in the cloud. Or if you've got third parties that are collecting M2M data like RFID data or anything that's really not going to be housed internally, you need some way to bring those data in. There's third-party data. We're going to talk about that in our example, where you've got brokers of either demographic data or any sort of public data sources, or just aggregators of data that no one business would ever want to aggregate themselves. Those third-party data sources are, again, going to be outside of your control, but are still going to be an important part of your analysis. Those are sort of where the data come from, but as we move down here, you see unstructured and semi-structured documents. Structured data that can be displayed row by column is the predominant set of data that have been traditionally used for data and data analytics and will continue to be. But unstructured data, things like PDF documents or comment fields on a website, there's data in there. There's information in there that we need to bring in, and in order to do that, in order to mine those data without incurring enormous expense of transforming them into data warehouses of structured data, we need new types of databases and data sources. So that's where you see things like MongoDB, which we'll talk about, Hadoop, and other ways to acquire these unstructured data and work with them so that you can structure them for data analysis. So the big picture here is that there's a wealth of data outside of the traditional warehouse that we need some way to bring in. So unstructured data, it opens the doors for business improvement. It's great. It's going to help us, but it imposes some new requirements. So it helps us in that we've got these new sources. We've got public databases and web content, chat logs. There's just tons of data, useful data that are being generated, and we don't have to incur, as businesses, often the cost of storing and maintaining those data. And where we do, there's low-cost infrastructure to support it. You can take a whole bunch of different data types. In an unstructured universe, it can be a car and a house and multiple different types of entities, and you can store them all in the same database without having to conform all of them to a common set of attributes, which is necessary for storing them in database or traditional relational database infrastructure. So that's great that on low-cost hardware and low-cost infrastructure, we can store these data, or someone else can store them for us out in the cloud using these same technologies, and it's economical to do so, which is great, but they may provide rich data sets with low-cost storage, but there's still a challenge because these unstructured data, at some point, they must become structured to perform analysis. They don't need to be stored in a structured format, but as soon as we're going to be asking questions or performing queries upon the data, we need to be able to structure those data so that all analytic tools will be able to work with them. These new technologies, Hadoop, NoSQL databases like Mongo and others, they're there to meet the challenge, but they're not as easy to use when you're actually doing this query, when you're trying to pull a structured statement out of an unstructured data source. because they require more of a programming type, for at least for now, a more programming type interface than the traditional sort of SQL or wizard based. So you're not going to move all of your unstructured data into the unstructured world, but you're going to need to structure those data and bring it together with your structured data when you're performing analysis. So the use case that we've chosen is Lavastorm, in concert with one of our partners, worked with a top 3 retail trading firm to do a market data assessment. What they wanted to be able to do was to identify bad trade fills. That is when someone either buys a stock too high or sells a stock too low as compared to the quotations that or the market was producing at that time. That's called a bad fill. They wanted to be able to do that so that they could report the bad fills and take corrective actions with their partners. If there's a latency in the time between a trade order and a trade fulfillment that is actually leading to one of these bad fills, there's things they can do about that, and they really wanted to keep an eye on it. In order to do this, they needed access to all trade and quotation data in every stock market in the world. That is not something that they were going to be able to scale up themselves, nor would you want to. You want someone else to collect those data, and you just want to make use of it. The other thing they wanted to be able to do was to assess changes in the quote over the course of plus or minus 5 seconds of a trade to see how much volatility there is in the quotes that are being offered, and see really how can they make changes to accommodate that volatility and lead to an optimal trade for their customers. So here, that gives them insight into that volatility and how it impacted overall trade performance. Trade by trade, this may be fractions of a cent, but in aggregate, it can present a rather expensive problem. So to solve this problem, why did Lavastorm work with our partner and use MongoDB? First thing is agility. It had to support rapid, random access of the data, as opposed to techniques which require a program to be created and to be executed across the data, where you're in a wait cycle there, and it takes a pretty technical skill set. Wanted something that we could just query and would present a similar interface to a traditional database. There are some limitations, but for just getting data out, because we're not performing the analysis in that database, we needed something simple. Self-service, we wanted, there's no way that we're going to put all of our data in the NoSQL tool. We need data from our legacy systems as well. So we needed some way to pull in the data from those NoSQL tools alongside our legacy systems without incurring additional IT overhead. Speed. As I said before, there's complication in creation of MapReduce type jobs, and then you have to wait for those MapReduce type jobs to execute over large volumes of data. That cycle can be pretty expensive if you're trying to perform an analysis where you're trying to see what the problem is, how quickly you can diagnose the problem, whether there's even a problem there. You want to be able to do this in a quick and agile way. So speed was important. And collaboration. If you have transparency and traceability that you'll see in the Lavastorm approach of the business logic and the data to which it is applied, it really engenders a collaborative discussion between the people who may use the tools which acquire different types of data and the people who are going to be providing the business rules that guide the analysis and will be working with the results. You don't want that sort of fractured environment where someone is given a set of requirements and goes off and builds a program and then comes back and produces results to the business analyst which are at variance with what the business analyst asked for, because only by performing some of this activity were some of the business rules teased out, and that leads to another iteration of this where the program has to be changed and new results presented. If that is not happening in a sort of collaborative real-time fashion, the latency of emails and phone calls and just sort of doing traditional analytics can slow things down quite a bit and lead to inaccurate results when you have a fractured, again, environment where you've got maybe a programmer or a technician who's not very well aware of the business rules, implementing something that may be sort of hidden in the results but ends up producing bad data. So back to our use case. This is just an example of, or an overview of how things are put together, and then we'll get into the software for a little bit. We've got market data. These are street quotes and trades that were provided from a third-party vendor of this information. This is across all of the markets every day, very large data sets, hundreds of millions or billions of transactions a day, combined with trade data that's coming from our this retail firm's customers, so when they're executing the trades. And then we can bring in miscellaneous data that we have, the customer portfolio data, to match what we're doing up to specific customers. We bring the raw data into the market data, goes into MongoDB. That was our database of choice here. And those data, along with the trade data, are used by the Lavastorm analytics engine to produce exceptions. We'll get into it in the technology to see what that means, but really it's where are there problems, where is the trade not occurring as I would expect, where are there those variances that I said earlier between the trade price and the quote price. Those are then pushed out to a database, a relational database now in-house, where a resolution user interface, which we're not going to show you today, but there's a resolution user interface where someone can manage those exceptions and look at the root cause of why these trades are occurring in ways that we don't want them to, resolve those things, and then change the business such that as we run these analyses over time, we'll see that we're continuously improving what we're doing. What this allowed us to do when we put this all together was we had the ability to leverage all of this market data to drive the excuse me, the operational insight that we would not have had if we were just working with the retail firm's data internally. Implementation costs were, in this case, were 75% less than the internal effort, given that you could offload a lot of the data infrastructure to the third-party provider so long as you had the capabilities of pulling in some of their data, and also the speed to which with which we could construct the analysis. It was 80% faster, so that also has implementation cost effect. And when we're done, we have a repeatable and scalable solution. That we have something that I'm going to show you a very small set of data, but because of the power of both the Lavastorm tool and the MongoDB unstructured document-oriented database, we can really scale this up tremendously. And we're not just left with a one-time ad hoc analysis of the data. We have something that can be run on an automated basis to make sure that we're continually improving our view of things and our business. Right before, this is the last slide before we get into the actual example, just a little bit about the Lavastorm analytics engine. It is a combination, really, of three major components. An ETL engine, which allows us to acquire data very agilely without a lot of infrastructure, but pull in all the data, do everything that we need with the data in order to prepare it for analysis. And then that analysis is performed in sort of a BI fashion, where we're asking questions of the data. We're seeing the answers rendered either as graphically as graphical data sets or as tabular data sets. We're doing so in an automated fashion, so we can run it over and over again. And we're doing it with, because we've been able to perform all of that ETL activity ourselves, we're doing it with a modicum of IT involvement, if any. And all of this really comes together because our particular approach, Lavastorm, is really a 5GL type interface, a fifth generation language, where you're not writing a series of SQL scripts or Java programs or something where you need a programmer to do it, and when you're done, you're left with a lot of sort of cryptic code. Instead, you're using visual models and in sort of a drag and drop way are creating a visual and very logical view of what you're doing rather than simply a technological view of what you're doing, what you'd see in a traditional programming type environment, or some BI environments even. So now I'm going to jump over to the Lavastorm Analytics engine and show you that trading example. This is the trading firm example. This is the actual model that was used initially for the project. It is later, as you'll see here, we're only working with small sets of data, but this was, and I'm keeping it that way for demonstration purposes, but this has subsequently been scaled up to deal with much larger volumes of data. But you're looking at the Lavastorm Analytics engine right now. As I said, it's a visual environment where we sort of drag and drop, create models like you see here, which represent the process of acquiring data, preparing data to do what you need to do, performing analysis by applying business rules to those data, and then performing further analysis to determine, once you've found the answers that you were looking for, oftentimes the wrong answer because it's a defect or an exception, you can perform impact analysis to quantify the impact of these and aid in their correction. That's sort of left to right, the approach here. What we're doing specifically in this example is we're acquiring trade data from this particular firm, requiring a small subset of about 83,000 trades. And we're then enriching it. I've only got one trade going in here at a time, which is pump one through at a time. We're enriching it using this database that was provided by a broker of market data to get all of the transactions for this single trade that occurred within 5 seconds of this trade. So if as I go through here and work through the model, you'll see that we're not just working with a model which represents the rules. We're actually also implementing them. So I'm going to re-execute this right now, and we'll see that these 83,000 rows are now being processed. That's that little arrow there. They're being processed on my laptop, so there's not the speed that you'd see in a bigger environment. But now we've just re-executed those rules against the data, and I have a set of data that I can inspect at every step in this sequence of data. These are those actual trades that we pulled out for. I narrowed it down to one specific trade and one specific symbol. But here now, out of this MongoDB, I've pulled in 11 rows for one row. And as you'll see here, there's a timestamp here that shows this is actually the trade that I was pulling out, but I've got 5 seconds on either side. We're going to use that downstream when we look for those variations in price across time, and also to look for those bad trades. So the second about this Mongo database node, it is a node just like any of the other nodes. That's what we call those little boxes in here that you'll see in the palette that I'm cycling through on the bottom. Each node really just acquires one or more data inputs. There's these little input streams that you see here, performs some sort of activity and produces one or more outputs reflective of that activity. So when I re-executed this, it took the one record for that trade. It went and queried the Mongo database. Now this is a database with gigabytes of data or terabytes of data, really, if you were pulling it off of the cloud. You'd be using a cloud-based API to pull this in. And you can see that very quickly you're able to pull in the reference data that we need and produce that set of trades. Then we go through and as I complete the data preparation stage here, I'm executing again and we're bringing in more data. I'm doing the things that I may have had to do or push on to my data warehouse team to do for me in the past, but I'm doing them in this tool. I'm doing things like removing duplicate records if they're found there. I'm changing some of the fields to different data types. If we look in here, I'm taking what was just if we look at the date in here, this date is just a big string but we know there's a date in there. I'm parsing it out and creating a real date type so that when I go and do my date arithmetic later on, when I'm trying to compare things by seconds of deviation between dates, I'm able to do that. Then I'm pulling back in using fuzzy matching to pull back that original trade with the 11 sets of quotes for that trade between those 5-second interval on either side. So I'm just pulling in the original record, which has it has all the data for the trade, and I'm appending all of the data for the attendant quotes. By the time I'm done with this data preparation stage, then I've got 11 records where I've got all the information about that original order, the original trade, the order reference, and whether it was a sell or a buy. And I've got the timestamps for when the trade was ordered versus when it was executed. But I've also pulled out of that database things like the price that was asked and answered, asked and bid on for that particular stock at those 5-second intervals. So I've got a reference there so that I can compare that to the price that actually was paid for that trade. So we have a really enriched data source now. Then we've got to do the rules analysis. We say, if I've got all of the data about the trade, what am I going to do with it? Well, first thing I'm going to do is create a single trade view. I'm going to take a single record and produce, back in here in the data, I've got all of the information about the trade, and I've also created through a pivot table, really, the time, at the time of the trade, what was paid, and on either side of the trade, that's T plus 5, T minus 1, etc. These aren't in order in this rendering, but I've now got the prices for quotes on both sides of those trades. I want to find out where there was, so the next thing I'm going to do is look for those bad fills. I described them earlier on in the slides, where a bad fill is really when I've either sold at lower than the sort of average sale price of the particular stock for that 5-second interval on either side, or when I bought at a higher price. In this case, we've only got one record, and we've just got it was a sell. So I'm going to then go back out to that database again and pull in some more data. This is really just another version of this join here. We've collapsed it down to one record. Now we're bringing it back out to 11. And we're going to look to see if there were any problems. So here I've got a matching record where we actually had enough variance in the price that we paid versus the price that we bid on that it could be considered an error. In this particular example, I don't believe that there is any more an error because we've refreshed the trades. But you can imagine when we run this on the entire 83,000 records and pull it in, even a very small percentage, very small hit rate of what we don't want to happen can be isolated here. And then we're going to store what we've got back into a database, which I showed on the previous slide, which is going to sit underneath a user interface so that when we find these errors, we can assign root cause to them, put notes attached to them, and allow human beings to go out and figure out what's wrong, correct what's wrong, and the next time that we run something like this, we're going to hopefully not see any errors again, or at least see that error population going down. So that's sort of what we did. The novel part of this is that in a self-sufficient fashion, without building a bunch of infrastructure, without forcing the warehousing of any of these data, or someone to build me the right views and the right tables in the right databases, I've been able to pull in data just out of an Excel file in this case. I've been able to call out to a massive database and acquire the enrichment data that I need, and I've been able to perform an analysis which produces actionable results. Not only been able to do it quickly, because the way that I perform this analysis is really I drag some nodes on here and I put some logic in them, and I run them and move on. I've been able to do it quickly, but I've also been able to do it thoroughly, because the people who are involved in this are both the technician who may build this out and the business analyst who can logically look at this and ensure that all of these rules are correct. It's a lot easier to explain a sequence of business rules like this than it would be to explain even a very well documented and commented set of code. And when I'm done, I'm not just left, if I were using a sort of traditional BI approach where I may do a lot of these same manipulations of the data and create some view of the data that would produce a similar result, when I'm done with that, I only have the answer. When I'm done with this, I have the ability to trace back through that answer and substantiate where I got that answer from and make sure that that answer is correct. If there's some sort of issue with the quote time that I'm producing, I've just popped it up here in the trace window, and I can see everything that happened to that quote time all the way back here, any one of these little data manipulations that I did, and determine where it broke or if it's broken. Just makes it a lot easier to involve more people in the process and ensure that that the answers that come out, that it's not the garbage in, garbage out problem. So that's a quick introduction to the particular tool, its application using not just traditional structured data, but unstructured data, and the actual use case that we talked about of pulling in these data to determine where there are bad fills. In this case, we didn't get a bad fill, but we can certainly, by looking at the data where we've derived some new things like the average sale price and the trades on either side, it's not hard for us to find where that has occurred. That concludes the demonstration portion of this webinar. So I'm going to go back into the slide and just talk a little bit about what we just saw. We saw that it's sort of an innovative way to use big data to drive an operational process where you're mixing in your internal data and pulling in an external source of large volumes of data to help you correct problems with an operational process, or at least give you more insight. We've seen complete transparency to the analysis process. If I had just, instead of showing you what I just showed you, if I just showed you the next slide and said we found 5 of these bad fills and that amounted to several $1,000s, you're probably going to ask me, where did you get that from? So I can take you back and take you all the way back through to the source data themselves and show you every incremental step that I took, every logical assumption that I made, everything that I did to prepare the data, and substantiate, really prove that what we did is correct, or correct it if it's wrong. In this case, we didn't leverage a multitude of data sources. We leveraged 2, but we leveraged 2 data sources from 2 totally different spots. In the real world here, the big data source, that MongoDB source of market data that I talked about, would be sitting up in the cloud exposing some sort of API for me where I could just pull it down for some sort of subscription. I sign up for this and I can pull in those data sources. So it's not even data that I have any control over. I'm not housing it. I don't want to, but I need it. And I'm mixing that along with one or many of the data sources that I've got in-house. Really, with the Lavastorm approach, we provide a raft of different interfaces to acquire data from a whole bunch of different data sources without the need for programming or any really sophisticated operation. So that really encourages you to bring in multiple data sources and have a really rich picture. The implementation timeline, because of what you saw me just do, and you can imagine how quickly we could build something like this together, it was significantly faster than the traditional approach. It really optimally, when you're doing an analysis like this, there are two people sitting looking at the same screen as we've just done and building it out together, rather than, as I said before, exchanging emails and phone calls and requirements documents and output spreadsheets. Let's just do it in real time and get it right and get it quick. That's where Lavastorm really, that's our software that I just showed you accentuates our goal is to really make business analysts heroes by giving them the power of a programmer without them having to be a programmer. To rapidly unify disparate data, as we saw, we could pull in data from different types. We could pull in a lot more data if we needed to pretty easily and intuitively construct complex analyses. That was a rather simplified example for the purposes of demonstration, but as more business rules are applied to the data and more data are pulled into the analysis, these things get very complex. But you have the tools in the software to manage that complexity by reducing a very complex sequence of steps to a more logical flow that someone can be taken through. And effectively deliver actionable insights and results. I say effective because we know that we can trust those results. And where we find something that we don't like, we can go back and correct it pretty easily. That's really what Lavastorm is bringing in, is a new, very agile approach to analyze, optimize, and control data and business processes. We've been around for about 10 years with the product that you just saw on the market. We've got 85 customers, and we're, as you'll see down here, we have a variety of different customers in a variety of geographies across the globe. So that really is what I wanted to show everyone today. I'd like to take this time now, because I've been speaking for 42 minutes without a breath, to pause and ask for any questions from the audience. Okay, first question. What do you mean diverse data can be stored in a single table without sharing attributes? Please expound. Okay, that was some shorthand that I used earlier on one of the slides. Actually, I can bring up a view of, I don't want to get too technical here, but bringing up a view. These are the actual data that were sitting in that MongoDB that I talked about. And you see that this looks kind of like a traditional database in that you've got for each record, this is one of those trades. You've got the stock symbol and you've got the time and date of it. The interesting thing about the unstructured or document-oriented databases like Mongo is that this particular record could then have 10 more attributes. It could have a bunch of information about, say, the person or the company for the trade, but this one wouldn't. So in a traditional database, for me to add 3 or 4 more columns to this, I would have to add them to every record, and they may end up being not populated for this particular record. But I'd actually have to change the database schema to accommodate those. That's a technical task. It can be a disruptive task. Whereas with something like document-oriented database, I can just say this particular record has these attributes. Now, in order to pull that into a table, in order to structure it, you have to find the common set of columns that you can use. So if there are no data for the other attributes that you add, they're not going to be in the database, obviously, and they're not going to be useful. So there's a little bit to deciding whether you want to use the subset that's in common to everyone or the superset, in which case you're going to get an awful lot of nulls. But the great thing about this is that you don't have to, a priori, when you're adding a new element to the database, you don't have to know that it has the same attributes as everything else. Another question. Lavastorm is a powerful tool. Thank you. What level of training is required to support this collaborative use that you've discussed? Kind of depends on whose hands are going to be on the keyboard. If you are a programmer or someone who has a really, really high skill set, a database analyst who's worked in SQL their whole lives or anything, I'd say you're not going to need any training. Just go to our website, download a trial, look at a couple of the videos that really translate how you do some certain things in Lavastorm to what you've been doing before, and you'll be off to the races. If you are a business analyst with a less technical skill set, and that's really the folks that we're targeting, because we really want to democratize data analyses or complex data analyses. If you're that type of person who's used to working in Excel over Access, or maybe a little bit in Access, but you know your way around an Excel spreadsheet, you know the difference between a number and a string data type, you know how to create a pivot table or use a pivot table. Within a couple of days, you're going to have to adjust a little bit, because you're not working with a spreadsheet. You can see the data as a spreadsheet, but the way that you're performing the types of activities that you would use Excel macro language for, VLOOKUPs or things like that, we have a little bit of a different paradigm for doing that due to the visual nature of what we do. But it doesn't take too long to map what you know to how we do it. And really, we'd see people productive after 2 or 3 days, and proficient within weeks, depending on what complexity of application they've built first time out. Another question, does big data analysis mean to some extent the obsolescence of traditional database skills, or does it mean everyone now involved needs DB skills and BI design chops? Oh, I hope not. No, these big data sources are not going to completely supplant traditional databases, because there's some things that they're not even that great for. Storing a large volume of data that are homogeneous, that all look the same, and collecting them on a really rapid interval, it's still, you don't need an unstructured documented oriented database for that. A traditional database is fine, and a traditional database is going to offer you some analyses and the ability to do some things in the database that something like Mongo is not going to have natively. If you're used to using databases, you can select star from table, order by, group by, and do some activities in the query. You're not going to really have as equally useful facilities or easily used facilities in something like, say, Hadoop, where you're going to have to build a MapReduce job to do similar functionality. There have been improvements in some tools to make it a little bit less of a learning curve, but that's there's so in toto it's not supplanting, it's more complementing traditional BI and data manipulation technologies. They're not going away. Another question, how will this help in different domains? For example, how can I show my artificial intelligence product, i.e. context analysis, via this instead of my particular use case? So if we're talking about the Lavastorm analytics engine itself, I'll bring you back here. What we've done in this particular analysis did not use any sophisticated techniques like predictive analytics or AI or neural or anything like that. We were really just being a stenographer in these nodes of pretty easily understood things like joining a couple of data sets and aggregating data down from 11 rows to one or something. But where you want to do something like that, our software has a couple of different interfaces for doing that. If I go down to the interface nodes here, you'll see we can bring in R. We find this is an increasingly popular way to do things like sophisticated regression analysis or k-means clustering, or there's a whole community of math PhDs out there who are contributing various functional components to R. So this node allows you to just take the data from here. I mean, I can't do it now because I don't have an R script, but execute the R job, and that will then return the types of analysis, either the output, either graphically or in tabular form, that you can then use downstream with the rest of Lavastorm. If you've got something else, if you've got a Java program, if you've got a web service, we can call out to the web service and invoke the sophisticated algorithm there and bring it back. Or potentially you can implement something, if it hasn't already been implemented, just using our Java or Python nodes in addition to the scripting language that the native nodes support. So there's a set of about 100 nodes that allow you to do the types of things that I've shown you here, and where those are insufficient for the task, we have interface nodes to bring in other techniques. Does Lavastorm only work with structured data? How do you get the unstructured data into structure in the first place? Well, as we see here, Lavastorm is working with structured data in the main, but we're pulling in potentially unstructured data in this node here. So as I said up front, you have to structure the data to perform the types of analytics that we do. So our MongoDB node, or if we've got a node for MapReduce, it's going to produce a tabular data set because that's what all of these guys are expecting downstream. That's not to say that if there are unstructured fields within the data set, we couldn't do some text analytics, semantic analytics, anything like that. But really, when you're pulling in data from a external system, you're going to impose some sort of structure on it. That doesn't have to be, we're not imposing a schema on this. You don't have to conform to a set of rows that we're prescribing or anything like that. However you get the data, whatever data are coming out of there is really opaque to us, and we're agnostic. But it will need to work between node to node. It will need to be rendered rendered down to some tabular structured format. Another question here, finding insights often requires data visualization. Are there tools you pair with Lavastorm to visualize results? Yes, there are. First of all, we do have some. I don't have them. They really didn't lend themselves to this particular example, but we do have some nodes here alongside our traditional tabular nodes. We do have some nodes here where you can say put down an area chart off of one of these, and that'll render it out right in here. That's sort of minimal visualization. Where that is insufficient, or where you've got a tool that you'd rather use, we've got a couple of different ways to go about it. One is, if you see me right-click on one of these output pins and I pull up my data set, this is the built-in data viewer Lavastorm. In addition, in this case, I've configured Excel and QlikView for working with the data. So just like I can send those data up to Lavastorm, I can pop the QlikView, and my data will now be pulled into QlikView. Now, in a real-world example, I would have already created a visualization in QlikView that I could use, and I'd just be refreshing the data. So you're not going to see much here. I'd have to build the visualization in front of you. But these data now from that output source are sitting in QlikView. I could, if we have the time, but I do have some other examples that show it a bit more clearly. So that is, we've got ClickView in Excel. We'll be adding Tableau integration via this right-click menu as well. And we built it in sort of an open fashion so that you can add more adapters. We also have nodes where we can, just like we can publish data out to databases, we can publish data out directly to the native file format of ClickView or of Excel or of Tableau at this point, with more to follow. Another question, do you have any templates for standard statistical analysis in your nodes? Great question. And it speaks to something which I haven't shown anyone yet. Let's say that we have this analysis and we want somebody to reuse it. This is not a statistical analysis, but let's imagine that we actually did bring in some of our statistical. I did some percent rank and I don't know, something else. Looked at some standard deviations and banded out the data. Once I've got this pulled together and I like the way it works, I can take this whole thing, or I can take a portion of it. I can, first of all, group it into a single node, which is called my analysis. So now you see I've taken a complex operation with multiple steps and I've just turned it into a single logical operation. And then I can convert it to a library node. So now alongside any of the nodes that are available from out of the box from Lavastorm, I can also look at my analysis node. So see, I dragged and dropped another one down there. And now all I need to do is hook it up to the data, the relevant data sources, and run. I'm going to have some issues here because I've got to configure it. But this now can be, this library of analyses can then be shared with others. So this template here that I've created can just be dragged and dropped into someone else's graph, or can really subsume a lot of the graph itself. And what I've given them is I've given them the ability to do something pretty complex without having to know how it works, but I haven't collapsed this down into a black box. It's actually got all the constituent parts in here, so someone can go and tweak. They can change some of this logic. They can remove some of the logic that I did, or disable it. They can parameterize this particular thing so that they could pass in a parameter like only run this for these particular stock symbols, or only run it for this particular region, or something like that. And again, they don't need to know how it works, but if they do, they can get inside that template. It's more of a gray box than a black box. And I think I've got time for one more question. So sorry if you already answered this. What languages are used in developing this app and for the solutions you deliver? There's probably two different ways to answer that question. I'll do both. The first one is what is the software written in, and that this application that you're looking at here is a Windows front end, and the back end is mainly Java with some C++, where we want our operations that are more computationally expensive to be fast. And this is either deployed on Windows, like you're looking at here, where both the client and the server are sitting on Windows, or in a client-server environment where the client that we're looking at here is sitting on my Windows box, and the server may be in a Sun M9000 96 CPU clustered environment or whatever, actually executing all of these things in parallel on the back end. That's the answering the question of what is our software written in. What do you need to, the other way to answer the question is, what do you need to know in order to use our software? Is there a language to this? And there is. These when you drag and drop one of these nodes down in here, this is a filter node, I need to give it some instruction. I need to tell it what I want it to do. And some of them, it's very simple. If it's a sort node, I just need to tell it what field I want to sort on. But if I want to do something more complex here, where I'm taking the bid price and the ask price from the input, I'm converting them to doubles, I am averaging them, I'm adding them and dividing by 2, and at the same time I'm doing some data conversion here from the time and dates. That's going to require using our scripting language. It's called BrainScript. It's pretty simple. It's not a full programming language by any stretch. It's more similar in syntax and in the set of operators to Excel macro language or SQL. And if I pulled up the online help here, you'd see that the types of operators that are available to you and the sort of syntax of the language. I think that about wraps it up as we're at 1:59. So maybe I'd turn it back to Ben. And any other questions that we weren't able to answer, we've got them all, and hopefully we'll be able to reach out to people and answer them in the future.
Awesome. Thank you, Mark, for a very informative presentation. Thank you to everyone for attending today's Modern Analyst webinar. I wanted to point out the webinar, along with the slides, will be archived at ModernAnalyst.com within a few days. This concludes today's event, and we hope you have a great day.